A Mars rover is directed to move within a square matrix. It accepts a sequence of commands to move in any of the four directions from each cell: up, down, left, or right. The rover starts from cell 0 and may not move diagonally or outside of the boundary. Each cell in the matrix has a position equal to row into size plus column, where row and column are 0 indexed. Size equal to row length of the matrix. Return the final position of the rover after all moves. Example: n equal to 4. The rover path is shown below: 0, 1, 5, 4, 8, 12. Rover moves to one position up, position unchanged, as the move would take the rover out of the boundary. Down, rover moves to position 5. Rover moves to position 8. Down, the rover ends up in position 12. The function returns 12. Function is complete the function rover move in the editor below. The rover move has the following parameters: int and the size of the matrix, string cmds. The commands returns int, the label of the cell rover occupies after executing all commands. Standard input 4, n equal to 4, 5. Command size n equal to 5. Right. Commands equal to right, down, left, down. One, two, three, four, 5. Sample of 8. Starts at end position 0. Right position 1. 1 keltade. Down position 5. 1. 5. Left position 4. Left no effect. Down position 8. Return 8. Seems simple yet. What will be the matrix size? Each cell int matrix size. Is it okay? N by n matrix size. You'll be given a string vector. You have to find the vector string, and the each value will be equal to right means I has to be incremented. Down means right means j has to be incremented. Left means j has to be decremented. In for loop, I means Then down means we are moving out of the array. So I will be decrementing I. Up means, is there any up option? Right down, left down. Right down, left down. Right means rover moves to position 1. Up position unchanged. Oh, okay. And up means position is unchanged. Boundary. Right moves to position 1. Up position unchanged. As a move, take the rover out of the loop boundary. Down means to position 5. So up is moving, incrementing I, and whenever you are incrementing or decrementing I, you have to take care that that index should not be out of the boundary. Each cell in the matrix has a position equal to row into size plus column. Row into size plus column. For this element, row is 0, 1. 1 into size. What is size? 4 by 4 matrix. 1 into 4 plus column. Column is 1. So it is 5. What is this function? The result equal to integer variable. What are the constraints? There can be a matrix of 20 by 20 size. There can be 20 commands. This question seems to be simple, but there should be something conflict, right? Let us try it out. And it's C++ 14, C++ 14, okay. Is study C++ bits. Okay, what all I need is a matrix has to be designed. Vector matrix size has been given. Int matrix of size, matrix size. Will there always be these commands of vector strings? What is the length of the vector strings? How many commands will be given for each? What is the error? Into matrices declared in row mode. Equality compare. Oh, sorry. So I'm assigning all the values with this, and I have to take that put string. All are capitals. Right, up, down, left, down, down. Right, up, left, down. If the command is right, I have to do, and basically what am I doing is if it is right, I have to do increment I by not I plus j plus equal to 1. they should not move out of the boundaries, right? When you are moving right, they should never reach out of boundaries. They must be less than, they must be, sorry, and they must be, when you're moving rightwards, the only condition is j must be between, j cannot be greater than or equal to 0, they must be less than or equal to matrix size. If that is true, then we can mount. Else if cmd is equal to up, for when you are being 0%, for up, when you're going up for any value, it should be up in the sense it is I. I value should not, I value should be greater than up value. I value should be greater than 0 and I value can be less than or equal to matrix size. And equal to left. When you are moving towards left, it is about j. J value must be greater than 0 and j value must be less than or equal to matrix size. And down, it is about shifting I. I must be greater than or equal to 0 and I must be less than. Down, right? It is for down. You cannot go down after matrices. It is up. Going upward means I must be decremented. I minus equal to 1. Left j, left j minus equal to 1. Down, down in the sense I plus equal to 1. This is how I values are being changed for each command. For each command, either I or j will be in mode. And finally, you will end up getting I and j values once you complete all the loop. So this is how it will be completed. And finally, what should I return? What should I return? The function returns 12. Return I and j value. This is my for loop. Return m of I j. So far so good. Let us try running this. Yes, I'm declaring a matrix over here, which is a matrix size, which is of equal n by n dimensional matrix. For int I equal to 0, I less than matrix size. For j equal to 0, j less than matrix size. Basically, I'm initializing my array with I is the row times matrix size, size of the element. size of the matrix plus column number. So this is what actually given in the statement, problem statement. Row into matrix size plus 1. For example, in this statement for this column cell, the I and j could be I is 0 and j is 3. 0 and 3 are the statements, like 0 m of 0 and 3 is equal to 0 into what is 4. For example, here for it is 4. 0 into 4 is absolutely 0. J is 3. So the value is 3. This is how I initialized my matrix. And I think it is not even required to move out like this. I can simply perform this for loop and I can just return out this with this matrix. And simply it's waste of memory, I think. This is just simple based question. Let us try if this satisfies the conditions. And how to explain the process, right? So, okay, I'm iterating over the vector, which is commands vector. As long as there are commands in that, if that command is right, I have to move a bit like this, right, towards right. So from 0 to 1, it is the shift. When you're moving towards right, it is changing the columns, and it's basically like column will be incremented by 1 every time you move. So I'm incrementing my column every time by 1, but make sure that you are always in the matrix itself. You should not come out of the matrix. For this reason, you should imply this constraints, which is your j should always be greater than 0, and your matrix, your j should not be matrix size. It should not be greater than or equal to matrix size. It should only be less than your matrix size. Like if you are at this position, you cannot move towards your right. So what you have to do is you just remain in the same position. That means you're not going to do anything else. So you're simply keeping quiet here. That's how this is the first for right. Talking about up, just need to move your I value by decrementing by 1. For example, if you are at 0, for example, you are at 4th position, you have to move by step 1, which means for 0. So here it is decrementing I by 1, add in I minus 1, but make sure that you are always in the array. So the boundaries of this array are as long as you are greater than 0. So if you are at 0th position, you cannot move upwards. That is how this is the boundary case, right? And if you are at the matrix end, like the last column row, even at this position, you can move upwards. So you can use equal to operator here. And this continues for same and for left as well. Like for left, you need to just move to a bit backward, like a left side. It is again a shift in columns, right? So when you're moving away from columns, it is simply decrementing the j value by 1, but make sure that j is between boundaries. For example, you can move left only when you are up to this element, which is till 7. That means till equal to the matrix size. So as long as it is less than or equal to matrix size, and it should not be equal to 0, because if you are at 0 and if you are not perform left, you will be coming out of the boundary. So this is that. And for down, you're just coming down from 8 to 12. So here it is again the same. You must be greater than or equal to 0, because if you are at 0, you can come down straight, right? From 0 to 4, it is possible. But when you are at 12, you cannot come down because the array does not exist for that value of that index. That's how this is being completed out here. And my end. So particularly what is that when you have to change I and when you have to change j has to be remembered. And finally, I am returning the value at m of I comma j. It is not required to initialize this array and something else. To be honest, you can simply execute, cut out this all. As you know, at the end of this for loop, you will simply getting I and j values. You can simply perform this operation over here. M of ij is the I into matrix size plus j, and you can return that value itself. I'll be trying with this. If it is satisfying all the memory constraints and time constraints, I will definitely do it. Otherwise, I will also optimize the code. Let me try running this code. So time limit is exceeded. I think your time should not be for of O(n) square, right? Let me try it out. I'm going to comment it out. So what I will be doing is I need this value. I into matrix size times plus j. We already know what is I and j. Straightforward, and I did everything well. I think this should satisfy your constraints. Oh shit, this is again try time limit exceeded. Now output. Your code did not execute within the time limits. Please optimize your code. For more information on execution time limits, refer to the environment page. This is what actually this does mean to tell me, right? Int over move, integer, time limit exceeded. It is just inside a for loop. Just traveling. The n is just 20 values. It should work fine. Matrix size is n. Size of the matrix can be at most 20 by 20 matrix. Commands can be 20. It should work 2 seconds. I'm only using else if constraint now. What else could you perform on this matrix? Let me copy paste this. With your own input. Matrix size is 4. String array comments write down. Length 3. Run. Why is it time limit exceeded? Return I times matrix size plus j. How can you directly trace out the value of this? You cannot do it now. Write down. We'll be moving it somewhere. You should you should at least move throughout the loop, throughout the commands. Print less than comment dot size. It is a vector. I'm not using any for loops. What is the time constraint? Simple version. Why am I perform well? Oh shit, what is this? Your code did not execute within the time limits. Please optimize your code. For more information on execution time limits, refer to the environment page. doing K++. No, that's nice. So basically that might let us try running all test cases. Nine out of 11 test cases passed. Shit. Test case 1 has failed. What is test case 1 and 3? Thank God, one is private, not public. 2 and 4. This is input 2 and 4, up, right, down, down. Your output 5. It is up. You cannot move up. If it is up, you cannot move anything. I'm doing right. Just simply remember up, right, down, down. What is my coding for up, right, down, down? If it is up, if mine is initially 0, it is absolutely up is 0. My I is initially 0. If I is greater than 0 and I is less than or equal to matrix size. I is greater than 0, condition false, so I cannot move. It is left like that. For the next iteration, right. I'm at in the same position and right. If it is right, what should I do? And if j is greater than or equal to 0, is j greater than or equal to 0? Yes. And j less than matrix size? Yes. J plus equal to 1? Yes. It has moved from 0 to 1. Down. J is 1 now. For down, if k is down and I is greater than or equal to 0, yes, and I less than matrix size, yes. When am I just traveling, why am I not changing the another index? I should also change the other index, no? How can I be in the same? When it is moving down, no. J should be same and only I should be changing, right? For down, let us read it again. So coming for down, so up and right, I have moved towards 0 to 1 and down 1 to 5. 1 to 5. 1 to 5 is it is simply I is sorry, here it is down. If it is down, I have to increment j by 1 as long as I is greater than 0. If it is down, I have to increment I by 1 as long as I is greater than or equal to 0 and I less than matrix size. I plus equal to 1. So I'll be coming to 5. Again down. What is our expected output? It's 3. Yeah. See, the question is simple, like you are given up. You cannot move up, right? It is 1. Down, it is 5. Down, it is 9. My up, what is this? size of the matrix is 2 by 2 matrix, right? Okay, this is a 2 by 2 matrix. We cannot move up. We can move right. It is 1. It is 1. Okay, and it is 0 up, right, down. We cannot move another down step. So it is 0, 1. Here we need to we should stop at this point, which is okay. What should be the value at this? According to the function I into matrix size, just 2. Sorry, 1. 1 into matrix size is 2. 1 into 2 is 2 plus 1. 1 into 2 into that is 3. Why am I getting 5? Let me trace out this code for this test case again. So for k equal to 0, k less than 2, k plus plus, if CMDS of k equal to right, now is it is up, yes, is I is greater than 0, less than matrix size, yes, I is greater than 0 and less than or equal to, condition false. So we are doing nothing. Else if, else if, else if. So k equal to 1, still k is less than commands net size, yes. If commands are 1 equal to right, yes. And j is greater than or equal to 0, yes. J less than or equal to, yes. J is plus 1. So I'm moving 1. And else if right is done successfully, now down. Else if commands of k equal to up, down. Next iteration it is down. Okay, if I is greater than or equal to 0 and I is less than matrix size, yes, less than matrix size, yes, 1 is less than matrix size 2, I plus equal to 1. I'm moving down, which is fine. Again down. Okay, if commands of k equal to 0 and greater than down, 1 k is j has become here j has become 1 now. 0, 1, 1 itself. I has incremented by 1. 1 I is 1 now. Then what is the value of j here? When j is kept unchanged, no, j has incremented by 1. When I said it is right, I have incremented j by 1. So at this point of time, I and j both are 1. Right? 1 comma 1. What should this written? 1 into 2 plus 1, which is 3. Then that is fine now. So 1 into matrix size is 2 now. That should work finally now. Where my code did wrong, it is doing exactly fine. 2 comma 4, yes, it is 2 comma 4. My matrix size value is 2, command size is 4, k value is 4. I'm executing for 4 times. If commands of 0, 1 is right, if that particular index is 0, is up. No, I'm not incrementing anything. This condition is false. I'm not moving anywhere. At this iteration, my I and j value are still same for the first iteration. For the second iteration, k is 1. Even for this iteration, there is no there is right option. Now my j will be is still 0 and j is less than matrix size. Yes, j plus equal to 1. My I is 0 and j is 1. So when there is no transition at all, here comes the problem. I'm just incrementing. That has to be done right, correct now. When it is right, it is 0 and it is right, my I value will become, now this position, I'm in this position which is 0 comma 1. Yes. For the position iteration 3 case, it is down. I plus equal to 1. Now my I is 0, it will become 1. And before my j has become 1. So my I and j are at this index here, 1 comma 1. Finally, I had another down. My j is incremented and right, j is incremented down, my I is incremented. Finally, another down. This will not be executed because I is greater than or equal to 0 and I is less than matrix size. Matrix size is 2. I is greater than or equal to 0 and I is less than matrix size. It is true. Matrix size 1 is less than matrix size. That's where it's gone wrong. When CMD is for the next condition, my I is greater than or equal to 0 and I is less than matrix size. Matrix size is 2. 1 is less than 2. Condition true. So I has incremented by 1. 1 in the sense, now my I has become 2. The condition is 2 into 2 plus 1 is 5. So this is where it going wrong. I understood. Mm, I have to manipulate this somehow. 2 hours were left. Mm, so it is should not be matrix size. Basically, when you are performing down operation, you are incrementing I. So when you are incrementing I, your down operation less than, and I must not be less than, your I can be less than or equal to matrix size minus 1. Right? Your I can only be less than or equal to matrix size minus 1. Less than or equal to matrix size minus 1 means 2 minus 1 is 1. If it is 1, can you go down? It should only be less than matrix size minus 1. If it is matrix size minus 1, which means 2 minus 1 is 1. So I cannot change. This will only constant for all, or this for everything. Actually, J should never reach matrix size minus 1. Matrix size. J should be less than matrix size. If J is less than matrix size, then it is okay. You can move forward. That means you can decrement the J value. For moving rightwards, J should be less than matrix size. If it is 2, it is 1. After 1, you cannot move rightwards. J must be less than matrix size minus 1. So J must be less than 1 only. Even for moving upwards, I must be greater than 0 and I is less than or equal to matrix size now. I should never reach that value. I less than matrix size only. For moving leftwards, J must be greater than 0, sure, and J must be less than matrix size. Actually, J should never reach matrix size. It will only reach till matrix size. Of course, 1 is possible now. That's cool. Should I click submit code? So let me repeat this code before I talk about it, before I submit. I'm just iterating over the loop. For before how I debugged was based on the test case available. I have checked it out and I got to know that I was also trying to move out. Like for example, even for the 2 by 2 matrix case, what I'm doing is when I have come here for 2 by 2 matrix, when I have come for I equal to 1, and I have used here like I less than matrix size. So I less than matrix size in the sense I less than 2, right? Even so, I less than 2 means for a 2 by 2 matrix, 1 is still less than matrix size, right? So I can move down. So that is wrong. So for that case, there should be 2 conditions, which is less than minus matrix size minus 1. Only should go search between 0 and 1. Like my matrix, if it is 2 by 2 matrix, my value should only between 0 to 1. That's how I missed their logic and I traced it back and I've shown it. Earlier everything was same, all test cases was passed, so I'm clicking submit code. Two stars between bars. What is the stars between bars? Given a string S consisting of stars and bars, an array of starting indices, start index, and array of ending indices. End index determine the number of stars between any 2 bars within the substring between the 2 indices inclusive. Note that in this problem, indexing starts at 1. 10 power 5 integer int n, each element I value is between 10 power 5. Given a string is consisting of stars and bars, an array of starting indices, start index, and an array of ending indices, end index. So there is a string, there is start index array, there is end index array. The number of stars between any 2 bars within the substring between the 2 indices. The number of stars between any 2 bars within the substring. The number of stars between any 2 bars. The number of stars between any 2 bars. The number of, sorry, I was thinking something. An array of substring indices and an array of index determine the number of stars between any 2 bars within the substring between the 2 indices. Determine the number of stars between any 2 bars. Okay. Within the substring between the 2 indices. we are talking about subsequence. This is a sequence of stars between the two bars. Any two bars within the substring between the two indices, inclusive. Note that in this problem, index starts at 1. Index is starting at 1. A star is represented an asterisk, star ASCII decimal 42. A bar is represented as a pipe, ASCII decimal 124. String manipulations. S is start index 1, 1 and index 5, 6. For the first pair of indices 1, 5, where the substring is star, star, there are two stars between a pair of bars. For the second pair of indices 1, 6, the substring is this. And there are 2 plus 1 equal to 3 stars between bars. Both of the answers are written in an array 2, 3. How did you get this? For the first pair of indices 1, 5, the substring is, note that this problem indexing starts at 1. Start index is 1 and index is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is okay. There are two stars between a pair of bars. For the second pair of indices 1, 6, the substring is 1, 2, 3, 4, 5, 6. 6 is this. Okay. There are 2 plus 1 equal to 3 stars between bars. Both of the answers are written in an array 2, 3. So we have to return an array vector. Complete the stars and bars function in the editor below. Constraints as I mentioned, length of the string, yes, vector, array, vector, end. What is end then? Start index, end index. 10 power 5 elements can be there. There can be 10 power 5 elements. Each character of S is either star or pipe. Standard input. So the logic is, I think, where is this example? So I have to calculate number of stars within bars. I should process till there exists, I should count a star when there is a pipe, when there is a star in between a pipe. I have to move throughout the array, throughout the length of this, definitely. And yeah, this can be done with the help of stack. Like if I take this as like this, and if I move through in the form of a stack, how can a string be stack? So coming from backward or forward. So if we are moving from end and the end element is a pipe, I can count all the stars in between that. So if it's simply a pipe, whatever it is. I'm going to type in. I'm unable to find. Let us think in the common process. While coding, I'll think it. Print I equal to 0, I less than yes dot size. I have to move throughout the length of the string. What is the use of start index and error index? You should only consider these indexes. And you not travel throughout the string. How can this be achieved? Length of the two strings is same. See, two vectors is same. Int I int I equal to 0, I less than start index dot length or size. I have to take another for loop. For each index in the array, I have to process that again. I should not process throughout the string. I should only process between the string of these indexes. For I equal to string yes of I have to calculate the stars in between. If S of I is a star, I should move between the string. If there are two consecutive pipes, this will check if S of I just of j equal to. If there are two consecutive pipes, it will check if they both are like if it is pipe, it will become one. And if there is another pipe, it will become two. So, so what am I doing actually is I'm taking I have to iterate throughout the number of elements, like number of indices that has to be matched. So it is basically either start index or end index. So I'm taking start index, I'm iterating for each and every like pairs, like each and every pair, I'm iterating throughout that. So I have taken that for loop. Now inside for this for loop, I should again for each pair, I should count the number of stars. So I'm taking another variable for loop for that pattern subpart, except sequence of that big star. Sorry, for the big sequence, string sequence, I have to take another parts, right? So for that reason, I'm taking another for loop, which is starting from I minus 1 to less than index. So it is 1 comma 6. So it is 1 comma 5. I should go till less than 5 in the sense 4. Okay. So as just indexing is starting from 1, the beginning index must be less than 1. So if I consider 0th index, like, so I took start index I minus 1. So it will make, if it is 1, it will make it as 0. So I will be scanning from first index, sorry, the first character of the string. In order to calculate from the first character of the string, I have to subscribe 1. Sorry, I have to subtract 1 from this. So that will make to 0. Now I can, what I say, I can access this particular pipe with that. So I'm using this minus 1. So if it is 1 to 5, 0, 1, 2, 3, 4, 4, till here it will be. So I need not change the end index. So it can be less than 5. So which is what? Same. So let us think if the first character that I got is pipe, what I have to do is I have to increment pipes by 1 so that my pipes will become 1 now. And if my pipes value is 2, let us come back again for this. Now let us move forward. My pipes has become 1 now. And sorry, now if pipe is 1, has become 1, right? Now else, so okay, that is okay, over. Now that first index for first iteration, my pipe has become a pipe and I have incremented it by 1. So this is false and this is, however, will not be executed. And now what I have to do is I should go back to the next iteration. Now the next iteration is star. So if else if s of j equal to star, it is star and pipes equal to 1. Yes, my pipes is 1 and it is star. So what I have to do is I have to incrementing temporary stars. That is, my temporary star will become 1 now. As it is initially 0, it has become 1. Now I'm going for the next iteration, which is again this, the another star. So absolutely this will be executed again. My temp stars will become 2 and it is a pipe. So if my pipes have become 1 plus 1, which is 2. Now when my pipes are 2, I have to increment my count stars with this temporary stars. Now my temporary stars was 2, right? I will be adding this count stars to my temporary stars, which is this. And okay, my count stars, I got 2 stars. Okay, now then I'll move back. I'll go back. Sorry, I will move forward, which is again a star. Now my if pipes equal to 2, I'm incrementing this and this my temporary stars is again 0 now. After this, I should take my pipe to 0 again. Okay, now my pipes is again 0. I check for the next character, which is 1. Which is this pipe. If my next index is again pipe, my pipe will become 1. Now my pipes will become 1 as it is incremented by 1. So it is 1. And then I will come back here for the next. Okay, forward till it is done. And there is no this. If s of j equal to star and pipes equal to 1. Yes, this is condition is true for the last character in this given string. Temp stars will become 1 now again, as it is 0. Now my temp stars is again 1. So there is no need of pipes is again greater than 2, because when it is becoming 2 and I'm making it 0, so there is no use of it. So my temporary stars will be incrementing and will be going on like this, and at the end of this I will be I have taken another vector to print the between, like, for each iteration. Like, actually this has to be done for each iteration, and this is for loop is completing here. So for each part of that, I'm taking this count stars for each subpart, right? I'm taking this count stars and I'm putting back into my resultant vector. That's how I'll be last at the end. I'll be returning result. Let me run this case. Compiled successfully. 0 0. Your output is 0. Expected output is also 0. Fine. Let me run again for all the test cases. Only one is passed. So is there all are private public test cases? Then that's great thing. So here it is okay. For this string, I'll dry run my code to better understand this. What is this one input? Okay. Is this start index or this start index? What is the public test case? Past test cases. One comma 1 comma 3. Start index. What will be the pattern of inputs? I think it is 1 comma 1, 1 comma 3, like this. Okay, so 1 comma 1. 1 minus 1 is 0. 0 to 1. So 0 to less than 1 means it should not be iterated at all. Sorry, for 0 less than 1 iteration will be possible. During that one iteration, there cannot be existing anything, pipes and all. There can only be star, and absolutely pipes will be 0 here. So for that, nothing. For this 193, from 0 to 3, that means 0 to 2. 0, 1, 2. There is 1 star, 1 pipe, 1 star. So there should be 0, no? Yes, this is matching. For this again, I'm starting from here, 1 and 1, 1 and 6. For 1, it is star, and it is 1 and 1. So 0 to 1, it is only iteration 1 again. It will not be done anything, so I'll be it like that. And 1 to 6. For 1 to 6, it is again, so 1 is 0 to 5. 0, 1, 2, 3, 4, 5. So throughout this string, I have to iterate. And for the first case, it is 1 to 0. There is only 1 star. There is nothing. And for this 1 to 6, there should be how many stars? Only if the initial is star, if it is s of 0, so my initially pipes is 0, so this is will not be executed, nothing will be done here. Then it is pipe, so when it is a pipe, my pipes value will become 1, right? My pipes is 1 now. And if it is 1, and for the next iteration it is star, so it is 1, and then my temporary star is 1. And next iteration is I got a pipe here, my pipe value will become 2 now. My count stars is temp stars, my count star is 1, so my temp stars is again 0 and pipes is 0. There is 1 star, that's fine. And I have to go iterate back again. 1 2, okay, I got 1 temp stars. If pipes equal to 2, count stars plus equal to temp stars, which is count star is 1, my temp star is 0, pipes is 0 again. So this is where something going wrong. If the previous existing star is 1, there is a star between this. So when my pipes is becoming 2, I can give it as 1. When my pipe has become 2, I can give it as 1. And if again I find another character, then I will increment and I will do it or run it again. Ah, that's great. So before I submit, I wanted to explain this again. So the logic is simple. Given a string s and a vector of two vectors of start index and end index, I'm pairing each and every value from start index array and end index array. And the first element from the start index and the first element from the end index will become one pair, and the second index from start index, or second element from the start index and the second element from the end index will another pair. So I have to find the number of stars in these pairs, like between pair 1, pair 2, pair 3, and n number of pairs. I have to find the number of stars available over there. So for this, I'm going to iterate throughout as long as there are pairs. So how many pairs can exist? As the start index length and the end index length is same, I'm going throughout through the length of start index. For each start index length, I should again go further. For this case, what I'm doing is, as the indexing are starting from 1, I have to take -1, which means in order to go through this, like here, it is 1. You're counting this as 1 according to the index values, like in the start index values and all. But as I'm habituated for 0, I'm taking it to be -1. So start index -1 to less than end index. I'm moving throughout it. So if I find a pipe, I will be incrementing by pipe by 1. Okay. And if pipes is 2, this can be done something when there is another one. This, as of now, let us go for the next thing. So if I found a pipe, and it will be moving throughout next, and if I get a star, I'll be counting the stars. So as long as I find another pipe, once I found a pipe, and when I find another pipe, till I find another pipe, I'll be counting the number of stars in between that. So once I found a pipe, I'll be counting the stars, and I'll be storing them in a temporary variable. And if I find another pipe, I will take these stars, I will consider these stars. If I do not find any pipe out there, like the next pipe, I will never consider these stars. So I will be leaving them out. So this is possible. This is what something you can see at the end of the cases. Now for this, I will be only counting these two stars as I found between a pipe and pipe up. There is no pipe out after this. So I'm not going to count this temporary star. That is what here I wanted to do this. When pipes is 2, I'll be taking this, I will be considering these temporary stars to my count stars. And I'll be assigning my temporary stars to 0 again. And my pipes will be 1. Because when you move throughout this, the pipe is again 1. And when you get, for the first iteration, you need 2 pipes. For the first time to consider stars, you need 2 pipes, pipes equal to 2. But for from the next iteration, you need not have again another separate like something like that, because the already ending one is considered one, and if you find one another pipe, then you can consider the remaining stars available out there. So for that reason, I'm going to do that, and I'm assigning my pipes to be one, and I will be checking throughout it for each pair. And if I found it temporary star, I will be incrementing it, and I will be adding to my count stars. And at the end, I will be adding to my resultant vector, which is result vector, and in returning this result. So that's all about this. If you found it useful, sorry, I'm thinking like the you class. Okay, that's great. It has passed all the test cases. Let me check it again. Yes, it has passed all the test cases. I'm submitting this code. Okay, I think 2 test cases were passed. Okay, time is also 1 hour 32 minutes were left. So that is all about this. If any sounds or no, if you found any sound, something like that, or it is, I'm in hostel. So basically there can be some sounds, but I didn't take out my eyes from the screen, nor neither I used any any digital phones or like any papers or book. I generally do work using paper and pen and paper. I basically solve questions using pen and paper. But for this stage, I didn't use any of those, and I did not choose reference from any other resources. If you found it like if you think I have not cheated, I have shown everything fair enough, I think you may consider this. Thank you so much for giving me an opportunity to present myself for your company. Thank you.